So when it comes to CNC codes, first you must sort of imagine the stock you are working with on like a y and x axis. So with the help of this graph plotter, I'm trying to visualize the block on a y and x axis so that I can show you how we would do the cuts moving from one point to another point by putting the block on a graph. Now the first thing you need to identify is the width of the block. Now in this case, the width of our block is 200. It's 200 millimeters, as you can see here. So like when you are visualizing it, it's like to be from 0, then here would be what, 200 on the x-axis. Then next is how long it is, and here it is, you can see it's 100. So on our x-axis, the height here, on our y-axis, the height here would be 100. Now the next thing I look for is the center line. So draw the center line here, and then if the block is 200 millimeters wide, then obviously its center would be, so here on the x-axis will be 100. So it's like 100 here. If here's 200, half of it will be 100. And the same way, the center line for, let's see, NK is okay. Let me try it here. The center line like this on the y-axis would be 50. It will be 50 like that. So we have these basic points. Now in order to do the cuts, we'll have to move from this point here, in order to do the cut, you have to move from here all the way to here. So you have to be at this point, if you can see, and then end at this point. Now in the question, okay, so now the next thing we need to find is this point here as an x and y coordinate, so that we can move from this point here to this point here. So when you come to the axis, we are trying to identify this point as an x and y coordinate. So looking at the diagram, it says that from this length is 120, and if the whole block is 200 millimeters wide, that means here and here have a remaining length of what, 80. Now if these two sides are equal, that means here is 40 and here is also 40. So on the graph, this side will be 40 on the y-axis, on the x-axis, and this side will be 40 plus 120, which is 160. So here would become a dash, here would become 160 millimeters. Now then we check the y coordinates. They are all at the center line. So for the first point, it should be 40, 50. And then for the second point, it is 160, 50. So we'll be moving from this point here to this point here. Now we know our coordinates. It's easier to move from this point to this point. So one thing we have to remember is that we have to account for the diameter of the mill, and then yes, so we just need to account for the diameter of the mill. Now in the question, the diameter of the mill was 20. So it's like you have to imagine putting, that means the length of the mill from here to here is 20. So you have to imagine as if you have to imagine placing the mill on top of the block. Now when you place it at that point, the mill, it will look like this, and then it will move across across from x4050 to x160y50. Now the center is what is aligned with the point here. So like, let me place it again. It's what is aligned. So like the center of the mill will be aligned with this point. To be aligned with the center here. So that is why when we're finding the coordinates, we do not find the coordinates for this point. We do not find the coordinates for this point. For this point, we found the coordinates for the middle, because that is what is aligned or is coincident with the center of the mill. The machine takes the center of the tool, it aligns it with the origin. So it's like it places the origin of the tool here, so it aligns with the center of the mill. So when we are looking at our coordinates, we always keep in mind the diameter of the mill, so that we will know how to pick the coordinates. So if we had picked the coordinates here at this point, then that means the mill would come, the center of the mill would come there to that point. It's the center of the mill which is coming to that point, and to be like that. If you had picked the bottom side, this side, then the center of the tool, mill or drill, either the mill or the drill, will come to that point. So we always look for the point where when we place the tool, the center, you need to remember that the center of the tool would be at that point, and then we drag across. Now in the question, the length freehand, the width of the hole, the width of the hole is 20. So that's why I think the question, they set the mill to 20. So that's just a quick reminder that is the center of the mill. That is what is aligned with the center, the point. So that's where we pick our points from. So that's why we don't place it at the top, we don't place it at the bottom. So wherever you're picking your points from, just know that it's the center. So if you pick this point, if you pick this point here, just know that this is how the tool will be at that point. It will be the center of the tool, and then that point. So you must always, when you are looking for the point, you must always account for the position you want. You must always remember the diameter of the tool, which is 20 in this case, and then the point, so that you know how to pick your point. So if we are picking, our point was here, let's say the cutting ended here, and we had to pick this point. That's why we'll pick the middle, so it will be 100 here and 50. So I will place the middle of the tool here, and then the, what do you call it, the middle of the tool here, so that we'll get the X and the Y exactly. So you must always look at the diameter of the tool and the cut you are making, so that you can pick your point properly. Before you start, the first thing you do when you're about to code is you tell the computer the dimensions of the block. Now in this case, so the code is stock, then backslash block, then comma, then is the width of the block, which is 200 in this case, then the length 100, then the height, which is 40. Then the next thing is the x coordinates, the origin, which is always 0, the y is also 0 as well, then the z is just the height, so you just type 40 again, then close. So it's 200, 140, 0, 40. And now when I run this, okay, I need a tool first. We have, okay, it has come. You see, we have our stock block with our width, length, and height. Now, the next thing you need to do is general settings. Now, these settings tell the machine the unit of measurement you are using, the referencing type you are using, then the feed rate. Now G90, there are two types of referencing. There's absolute and there's incremental. Now in our case we'll be using absolute, so we'll just type G90. Then the next one is the unit of measurement we are using. We are using millimeters or mmgs, so the code is G21. And then the next thing to tell the machine is the feed rate code, which is G95. Then we are done with these settings. Next thing is the tool we are using. Now we shall be using the mill tool, because when you are removing parts you use the mill tool. Now the mill tool's code is open bracket 2, then backslash mill. Now we have the diameter, the corner radius, the height, and the taper angle. Now we would ignore the corner radius and the taper angle and just focus on the diameter and height. The question he gave us, the diameter was 20, corner radius 0, and the height was 50, and the taper angle is 0. And then we close the bracket. Then next thing we do is to add the color. The color isn't for the machine, but it's to help you see whatever you are milling. Now it's an RGB, which is red, green, and blue. So if I want green, I'll do 0. I'll keep the green full 255, which is the max value. Now just keep the blue also 0, and that will give me green when I'm cutting. Then we have our first line of code. So our first line. So what's the first set of codes has done is that it has picked the mill tool. Now we have picked the tool. We need to tell the tool to start spinning, and that's the code M03. use M03 to tell the tool to start spinning. So you type M03. Now as it's spinning, what is the spin rate or the spindle speed? So let's take a spindle speed of 1500 revolutions per minute. So we just type S1500. Now when we assume that wherever we are picking the tool from, if we move it immediately, it may collide with the block and then damage it. So as you can see, if you look here, you'll see that the computer sets the top of the block as the origin. So we assume that wherever the tool is coming from, if we move it immediately, it will collide with the block and damage it. So the next code is a G00 code, because you are telling the machine to move without cutting. So G00, then Z5. Now that means that the machine will raise the tool 5 millimeters above the top of the block. Then the next thing we do is we put the feed rate, and we'll type FA80, which is the speed at which the tool is moving, or the machine is moving the tool. Then next code, N3, is after we've raised the machine, we are now telling it to go to the first point, our point for cutting. So our first coordinate was 40, 50. So still under G00. Once you've typed G00 in a previous line and you're still moving without cutting, you don't need to type the G00 again. So all we will type is X40, Y50. The machine should move to our point. So when I run it, you see that the tool has moved to that position. Now the next line of code we will do is we will tell the machine to now go downwards inside the block. So we'll type G01, which means now we are now cutting. It means you are now going to be removing material. So G01, and then Z minus 20, which is how deep the tool is going inside. Once again, we are using absolute referencing. So if you want the tool to go inside the machine, or it should cut inside to a depth of 20 millimeters, because we are Z5, you don't need to type Z minus 25. That means it should first come down to the top and then go down minus 20. No, this is absolute reference. So when you type Z minus 20, it will go to a depth of Z minus 20 from the origin. So the tool will imagine itself as if it's on the origin and just go to the minus 20, because we are using absolute. So when I run this code, as you can see, the tool has now gone inside. It has now made a cut. Now that we are inside the block, the next thing we want to do is we want to move from this point all the way to the other point. It should cut through. Once again, we are doing linear movement. We don't need to type G01 again. No. All we need to do is type the coordinate of the endpoint, which is X160 and Y50. Now, if you are moving from one point to another, let's say you have if you are moving from one coordinate to another, you have either the X coordinate being the same or the Y coordinate being the same. You don't repeat the one which is the same. In this case, our Y is the same. So we'll just tell the machine to go to x116, and it will interpret it as going from x40 y50 to x160 y50 on its own. So now when I run this code, as you can see, it makes the straight cut from x40 y50 to x160 y50. Now the next code, we are done cutting. Now we are raising the tool once again. Raising the tool, we are removing the tool from the block so that when we are moving it, it doesn't cut again. So our sixth line of code will be G00 because we are moving without cutting, and then Z5 to raise the tool up on top of the block. So when I run it, as you can see, the tool is now above the block like that. So this is what we want. The next piece of code, it will tell the machine to go back, or to place the machine back where it was. Now here our home, and we call that place the home of the tool. So our home was x0 y0. So we'll just type x0 y0. We don't need to type g00 again because we've already typed it in the previous line. We run it, then we see that the tool has now returned back to its home. Next line of code is we tell the spindle to stop spinning, and we do that by typing M06. And the last piece of code will be to tell the spindle to end the program, which means we are done with our cuts, and the code is M30.